Hello everyone, welcome to my talk, Building Scalable APIs using Flask and Docker at Flask Conference 2021. I'll start by giving a brief introduction about myself. I am a generalized software engineer and a machine learning engineer, and I'm also a community builder. Currently, I work as a technical instructor at Flask Tech Academy, and I am a global ambassador at Women Tech Network and a very strong advocate for females in tech. These are my Twitter handles, my Donery and my LinkedIn handle right here. You can reach out and we can connect. So I'll jump right into our topic, our talk today, that is building scalable APIs using Flask and Docker. First of all, we will start by understanding the Flask framework, or what is Flask. Basically, you can say Flask is a micro web framework that is written in Python programming language, and it is majorly used for creating APIs. Flask is simple, yet it is a very, very powerful web framework which is designed to get started quickly and very, very easily. By this I mean, even people who have basics of Python programming language can really interact very well with Flask because it is very beginner friendly and it is quick to learn and very easy to understand. Despite all that, Flask also has the ability to scale up to complex applications. And by saying Flask is a micro framework, what I mean is Flask does not require specific tools or plugins to run. It is very, very lightweight and flexible. And one thing I love about it is also very highly structured. And this is why I always prefer Flask framework over other Python frameworks out there. So I'll go on to talk about or briefly define what Docker is, because as I said, our topic is building scalable APIs using Flask and Docker. And Docker is an open source containerization tool which majorly deals with the deployment of applications and the environment in which those applications run. When deploying a Flask application with Docker, it allows you to replicate the application across different servers with very, very minimal reconfiguration. Like when packaging up an application in a container, that it enables, like, the container can be moved across platforms and different infrastructures, and this enables one to use the application wherever you move it, because it has everything it needs to run successfully within it. I guess up to there, everyone has a brief definition or a brief understanding on what Docker is or what it contains. So on the next, I'll tackle API, and because whatever I'm dealing with today is how can we build scalable APIs that can work with high performance, or it cannot scale down whenever an application grows. And API is an acronym for Application Programming Interface, which briefly defines a set of rules that describe how computers and applications interact with one another. In other terms, it acts as intermediary between the front end and the back end of an application. In Flask, API is a collection of HTTP routes that are designed as low-level entry points into the applications. What I'm trying to mean is, instead of defining routes and view functions that return HTML to be consumed by web browsers, these APIs allows the client to work directly with the application's resources, leaving the decision of how to present the information to the user entirely to the client. And APIs are majorly confronted by some few challenges, and the two main challenge that confronts APIs: there can be an API where no one is using them, and there are APIs where everyone is using them. So in such cases, how do you manage hundreds of thousands to millions of users? Or how do you keep track of unique access tokens and keys and figure out which endpoints are being used and by whom? Or beyond managing users, how do you foresee demand spikes? And if so, you can scale up and down intelligently. And what architecture do you need to support dynamic scaling to avoid downtime and self-healing within your infrastructure? And this is where scalability comes in. And when we speak of scalability, maybe those who do not understand what scalability is, or why do we need to scale APIs? Scalability, it is the capacity of a system to scale up or down in performance and cost in response to changes in application and system processing demands. Like in the modern world, it is very necessary for applications to have that capability to scale, because an application can be developed today and go from relatively unknown to viral in a matter of hours. This is why we emphasize on building APIs that can accommodate applications. Developing applications and APIs that can accommodate growth. And you see, in the modern tech world, we develop software, but we do not know, like, when will this software gain popularity, or how much traffic will this software or API or application hold. So it is good, even when designing and developing or building APIs, to have that aspect of scale in mind. And I'll tackle on how to scale our APIs. And first of all, scaling APIs is not a simple thing, and also at the same time is not a very hard thing, as I will say. But there are some practices that really help us, or that can really help us to scale our APIs. And I'll start by mentioning a few, or which in my case I found very interesting, because making sure your API scales both in terms of use cases and load is a critical for success. It is a critical for success of a business or an application. And in this section, I'll just cover the following scaling best practices and tips that will help us ensure that our APIs are future proof. And my number one is scaling throughput. And as the number of users of an API grows, the throughput, which is measured as the number of API calls per second, increases. In this section, I'll talk about various ways in which we can optimize our API to support this growth. And one is measuring and finding out the bottlenecks first before starting to make changes for the scaling. Also, we can avoid premature optimizations. Like, scaling optimization obviously come at a cost, and some of them can increase the development time of your application. So I would suggest, unless you have scaling problems, you probably don't want to add that complexity to your API. Also, I would prefer horizontal scalability over vertical scalability. When I speak of vertical scale, I mean vertical scale is a simple way to scale your API by piling up on more hardware, like fast processors, and maybe adding up more memory. That will certainly grow your software. But then you'll need space and hardware continually, which at the end of it all gets generally all expensive quickly. And my reason to choose horizontal scaling, it is because horizontal scaling means adding more servers instead of adding more hardware. Scaling vertically makes more sense because it's more cost efficient, but it eventually have to scale horizontally to manage volumes. Like, scaling horizontally gives you that capacity to manage data volumes. And you see, APIs sometimes can really have a lot of traffic, and going for horizontal scalability, I think that's what I would recommend for me. And the second thing, or the second practice on ensuring scalable API, I would say, is evolving your API design. Like how you design your API, you can evolve it to something that is more compact. And in these, we can implement several ways to address this scalability and performance problems, because API design sometimes come with a lot of scalability and performance problems. And some of the ways we can counterattack this is by developing or evolving our API design. And one thing we can do to make sure our API design has evolved is adding new API methods. You see, this is another way to address scalability and performance problems, because if you have some expensive APIs, you might want to dive deeper into the use cases they are serving. Sometimes us as developers might need only a small subset of the data from your API responses, or as in the GitHub case that we just looked at. We might be working hard to assemble data that isn't easily accessible with the existing APIs. So if us as developers can only either request everything or nothing, then we may end up receiving full responses and ignoring most of the payloads. So it's possible that the data we need is expensive for computation. So it's difficult to remove or change APIs after they're in use, but adding a new method is easy. So new methods can deliver the data your developers need, while addressing the performance and scale issues of the existing API. Also, another way to address scalability and performance problem is by supporting bulk endpoints. Sometimes developers need to do the same operation on several items, like looking up or adding multiple users. Okay, this often requires doing several individual API calls. Supporting bulk endpoints so that developers can do the same operations in a fewer calls can be helpful for scaling. Bulk endpoints are more efficient because they require few HTTP round trips and can even help in reducing load on a database. And the last point I'll say on addressing scalability and performance problem is on adding new options. Like, you can add to filter results when your API begins returning a number of objects. So it is important to consider providing options to filter the results. This way, developers can limit the number of objects returned to those that they actually need. So this makes your API more scalable. And different APIs need different filters depending on how they are used. So you can you can add new options like filter results, like search results, etc, that helps returning a number of objects that are only necessary. And yeah, that's those are the 3 main points on how to address scalability and performance issues or performance problems by ensuring our API designs are evolved. And the next thing is paginating APIs. So in addition to scaling throughput and evolving our API design, paginating APIs can also help with scaling. Quite often APIs needs to handle very large data sets. Like an API call might end up returning thousands of items. Returning all these many items or too many items can obviously overload the web application backend and even may slow down clients that can't handle large data sets. And for that reason, I suggest it's very essential to paginate large result sets. This splits long lists of data into smaller chunks and minimizes response time for requests and making responses easier to handle. So, as a developer or while building APIs, it is really essential and very important, and I insist, like, it is really essential to consider paginating your APIs, especially if they are returning too many items. It is very bad when a client asks for a request and the request is returned after a very, very long time. The clients tend to be bored and probably will not consider using that API ever again. And to ensure, like, you design your API that paginates well, there are also some practices to consider while paginating your APIs. When implementing pagination, I would suggest, like, one should not forget to set reasonable default and maximum values for the page size. Also, I would say avoid using offset-based pagination if clients will run queries with large offsets. And if your API does not support pagination today, introduce it later in a way that maintains backward compatibility. When implementing pagination, return the next page URL pointing to the subsequent page of results. An empty or null next page value can indicate the end of the list. So by encouraging clients to follow the next page URL over time, you can change your pagination strategy without breaking clients. And on my next section, those are the things I've talked about: scaling APIs. I've talked about scaling throughput, evolving API decision, paginating APIs. These rate limiting APIs. When we talk of rate limiting, a rate limiting system controls the rate of traffic sent or received on a network interface. You see, often when API providers discover the need to rate limit APIs the hard way, like in many instances, it is important to discover this need to rate limit your APIs, because when an API becomes popular and suddenly sees a surge of traffic that potentially affects the availability of the application, developers begin exploring rate limit options. And there are two very key reasons why API should do rate limiting. And one is to protect the infrastructure while increasing reliability and availability of the application. And number two is to protect your product. When I say to protect the infrastructure while increasing reliability and availability of application. What I mean is, you do not want a single misbehaving developer or a user to bring your application down through a denial of service attack. And to protect your product, you may want to prevent abuses of your product, like mass registration of users or creation of a lot of spam content. So this is why rate limits are essential, because they help to handle surges in traffic or spam by making your application or API more reliable. They safeguard the infrastructure and products and also protect developers. And on our number 5, this is developer SDKs. Developer SDKs, generally it's a developer software development kit. It consists of a set of tools which allows developers to create application on a specific platform. You see, by providing SDKs, you're not just simplifying the integration effort required, you're also helping developers follow the best practices for working with your API. So when developers are able to follow best practices, that will in turn create more optimal usage patterns for your API, which will help you scale. Yeah, and I guess that's it about scaling APIs. So this section we'll talk about building APIs using Flask. Assuming you all know a little about what Flask does, you're finally ready to jump into implementing a small API with data that we define right in our application. And this slide shows a file that I created, and I named it my api.py. So we start by importing Flask, and then we import that module. Like from Flask, we import request and JSONify, then we instantiate our app, and then we create some test data for our catalog here, which is in JSON format. And then we defined a route which returns a function named home, and when you run this, it will return a h1 tag with a header 1 title, Python programming books, and a paragraph discovering Python programming language. And so there's a route that returns all the available entries. So this is an example of an API that when you call it, it will return all these books above here. That's why I defined it as I defined the function and called it API all, that returns JSONify books, these books. So when you run our application by running Python api.py, it will, and you go to this route, it will definitely give you books. Like, it calls this API that returns the books there. So that's just a very simple and basic API call that I made. And if you've gotten this far, you've created an actual API. You should be celebrate. Onto our microservice architecture. This that enables agility and scalability. So microservices architecture has risen to prominence because it is designed to scale, giving developers and businesses the flexibility and agility they need to build, edit, test, and deploy application at a granular level, resulting in shorter iteration cycles and more efficient use of cloud computing resources. Or what am I talking about? Like, developers choose to divide the functionality of an app into small, independently running microservices, which are then loosely connected via APIs to form a microservices-based application architecture. This architecture offers great agility and pluggability because enterprises can develop, deploy, and scale each microservice independently. Also, it helps in reducing complexity and maintenance issues a lot easily because of separation of concerns. And this is why I decided to use Docker, because Docker allows you to containerize your microservices and simplify the delivery and management of those microservices. Containerization generally provides individual microservices with their own isolated workload environments, making them independently deployable and scalable. What do I mean? Like, when you separate your application into different concerns and probably one fails, you do not need to work on the whole thing, but you can isolate that one concern that has issues and operate on it. So here is my Docker file. So to deploy our API on Docker, we first create a Docker file and realize how the Docker file has to start with a capital D Docker file, and then from our Docker file we define it has to have at least 3 commands. And basically this, you say, like, from Python, because you're working with Flask, you copy from the local file to the Docker image file, then you copy the requirements.txt file from the local file to the Docker image file. This requirement.txt contains the dependencies, our dependencies. Then you can run the pip install to install the dependencies on your container, and then you expose the ports on which to run, and then you have to write the command on which you run your API. That is why I called my Flask application, or my Flask file, I called it api.py, and the command was, when you want to run that API or that file, you run by the command Python app api.py. There's something to note here. Scalability is very critical for API platform growth, because APIs that are built without scale are considered, or will consider, suffering poor usability. They will have limited availability, and they will have a lot of security issues. And security is very crucial in a business or in an application. And a great API is intended for optimal consumer experience, similar to how a great UI is created for optimal user experience. Remember that when creating an API, you are assuming some responsibility for the application that others may build with it. So be very keen, and while building APIs, ensure that you build secure and scalable APIs that will not bring problem or will not arise issues in the future when they will need to accommodate growth. Thank you for the talk, and thank you for listening to me. Again, I'm Emma Donery, and we can connect on Twitter, on LinkedIn. You can check my articles on dev.io. I have written some articles about Flask. You can check them out.